Hello, my Math 7 children. Today we're going to get started on 6-1 and 6-2. We're going to combine these two because 6-1 is just adding and subtracting one-step equations, and 6-2 is multiplying and dividing one-step equations. So we're going to kind of combine them together just because you have seen this in the past. So to get us started, you're going to list as many keywords as you can for each of their operations below. So add, list as many as you can, subtract, multiply, and divide. Go ahead and do this on your own first to see how many you come up with, and then go ahead and push play to see the other ones that I've come up with for you. Alrighty, so take a look at all of the words that I have come up with. If you have something on this screen that I don't, well done. If you don't have something that maybe I have down here that might help to write it down, because this is your notes packet and this is something that you look back at. So if you need to, go ahead and pause the video and include any of the other words that I have included that you do not have on your notes. But if not, we're just going to go ahead and move right along. So keep these items in mind because the only difference now from chapter 6 and chapter 5 is we're going to translate equations rather than translating expressions. So let's look at this first one. The word is actually for this one. So let's go ahead and write this kind of up here because I think this will be something that we need for the rest of this chapter. Is represents equals. So is represents an equal sign. So just kind of keep that in mind when you're writing these because we haven't really seen that yet. So for this first example, it says 6 is. So I know that I'm going to start right there. 6 is. So I know that means 6 equals. And then we're just going to write similar to the expressions that we did from last chapter. So 4 less than triple a number. 4 less than I know means that I'm taking 4 away from something else. And then triple a number, I know that this means that I'm multiplying. So tripling some number, I'm just going to use the variable x. So I'm going to start with that because I want 4 less than that. So 6 is 3x. And then the next thing that I have would be that minus 4. Now, if you'd like to see with the variable on the left side, and you'd like to rewrite this using the commutative property and write 3x minus 4, and that whole thing equals 6, that's okay. These are the same equation. Just like I said, just using that commutative property, I've switched them around. It's totally up to you, but no matter what, your final answer when we get to actually solving them out, your final answer, that variable has to be on the left side. So just kind of keep that in mind. But this one is totally fine, but like I said, if you'd like to switch them around, feel free. All right, so we're going to continue just translating to get that practice in, and then on the back side of these notes is when we're actually going to solve them out. All right, so let's go ahead and take a look at what we've got. So we have half of the difference. So half, if I know I'm cutting something in half, there are two ways to write this. You're cutting something in half, meaning you're taking some amount and you're dividing it by 2, or you can take half of something. So if you look up at those words up above, the word of is like multiplication. So if I'm taking half of something, I could take 1/2 times, or like I said, that expression divided by 2. So I'm going to use that one first. So half of, and then what I have next is the difference of 7 and a number. So I know from up above and also just from before that difference means that I'm subtracting. Remember, you always have to do this in order. So 7 and then a number. Because that 7 comes first, it needs to be 7 minus that number. And remember back to that is represents the equal sign, and then my final item that I have right here is -12. So once you write your equations or even your expressions from last chapter, always go back through and read that translating phrase again to make sure that it makes sense. So half of, or half the, which means the same thing, half the, and then difference, I know is subtraction, of 7 and a number, so 7 minus x is or equals -12. Now, like I said, you can write that using that half of, or I can write the expression 7 minus x because that's the difference of 7 and a number. And then I can just divide it by 2 if you would rather do that than take half of that answer, and that whole thing equals that -12. So either one of these works. It's totally up to you. It does not matter which one you use, but like I said, half could be multiplying by a half or dividing by 2. All right, so let's move along to example 3. So right here, we see the product of a number and -4 less 5 is 7. So you kind of hear how I'm pausing. So the product of a number and 4, so that's kind of one part of my expression. And then I have less 5, and then that is 7. So let's start with what we know. So the product, I know that product from up above is multiplication. So I have the product of a number and negative 4. So that could be written a few ways. X times negative 4. That could also be X parentheses negative 4. But even better than both of those would be to have that coefficient, remember that vocabulary word from last chapter, that coefficient to be written first. So I'm going to write that as negative 4x, because that's the product of a number and negative 4 with that coefficient first. And then less 5. Well, that just really means that I'm taking away 5. And I've also written that word less up above in that subtraction column so that you could see this. So minus 5, and that whole thing is 7. And we know, remember, is that equal sign and the number 7. Alrighty, and so then the next item, the last one before you try it, is we're going to do example 4. But before we get started on this example 4, I want you to write the name of your favorite animal off to the right side of this example. So you see example 4, and then it says 5 is the quotient of a number and 9. Right there by that word 9, go ahead and write your favorite animal. So it can be an animal that swims in the ocean. It can be an animal that walks on land, 2 legs, 4 legs, whatever it may be. But I want you to write your favorite animal, if you are listening, off to the right side of this example 4. All right, we're going to continue. So 5 is, I know that means 5 equals. And then I have the quotient, and we know quotient means division. So you can write this 2 ways, either using that division sign or using that fraction bar. I'm just going to stick to the fraction bar. So the quotient of, and then it says the number, so my x, and 9. So it's going to go below it. And then the last part that we have is increased by 6. So I know if I'm increasing something, I'm adding 6 to it. All right, so hopefully you feel pretty good with these writing and translating phrases into equations, because like I said, it is very similar to last chapter, but only now instead of just an expression, you have an equation. So why don't you go ahead and pause this video, and I want you to work, just set up example 5 and example 6. Go ahead and pause. Alrighty, so take a look on example 5. I have written, probably this top one is probably our best bet. This negative 2 parentheses x minus 5. But I've also written the other ways that you could write this. So down below you have x minus 5 times the negative 2 equals 0, or x minus 5 parentheses negative 2 equals 0. But because it says the product of 5 less than a number and negative 2, so I'm multiplying that entire expression, 5 less than a number, with negative 2 to equal 0. And then also for example 6, I have negative 8 is, so negative 8 equals 11 more than. So remember this 11 more than. Yes, I know it's just addition, and addition is commutative. Please put that at the end of that part of your equation. So triple a number, so 3x, and then plus 11. Let's go ahead and turn over our notes. Alrighty, so now we're going to translate and actually solve out these equations. So again, because we're just using a number, I'm going to continue just using x. But here pretty soon when you get started on the word problems, you're obviously going to have to define those word problem or those variables again. But for now, I'm just going to continue using that variable x. So right here, 3 less than a number, and then is negative 2. So 3 less than a number means that I need a number that I don't know, minus 3 is, and I have a negative 2. So once you set up, again, read through that phrase to make sure that it makes sense. So 3 less than a number, yep, is negative 2. Perfect. So now I'm just going to solve out my equations. So to solve this, I always want to get that x variable all by itself. So I'm going to do the order of operations backwards. Well, I know that minus 3, the opposite of a minus 3 is a plus 3. Whatever I do to one side, I have to do to the other, remembering back this from last year. So then all I have left is x and then plus 0, because if I had negative 3 and then I added to it. But do I necessarily need that step? No. So I'm just going to say x equals, and then when I have negative 2 and I'm adding 3 to that, I end up with x equals 1. And then if you'd like to get in the habit of checking, absolutely. All you're going to do is plug in that 1 for our x that we have. So here's kind of my quick little check. I have 1 minus 3 to equal negative 2. And I know that 1 minus 3 is just negative 2. So negative 2 equals negative 2, and that's a true statement. So there's just kind of the quick check. All I did there, I know I did it fast, but I just plugged that 1 in for our original equation, and I know that it makes sense because our final answer is a true statement. All right, and then looking at the next one, 8 is the quotient of a number and negative 2. So again, 8 is, I'm going to start there, 8 equals. And then it says the quotient of a number and negative 2. So quotient I know is division. And the number is listed first, so x over, and then my denominator is negative 2. 8 is the quotient of a number negative 2. Good, so we feel good about that. Now I'm just going to solve it out. So to get x again by itself, I want to get this number all by itself. So because I'm taking that number divided by negative 2, the opposite of dividing is multiplying. So I'm going to multiply by this entire denominator to get that numerator all by itself. And then whatever I've done on that side, I need to also do on the other side, multiply by negative 2. So when I multiply that out, I get negative 16 equals x, but I'm not done because your final answer, that x variable, has to be on the left side. So using the commutative property, I'm going to switch these two around, and I'm going to rewrite it as x equals negative 16. And again, if you'd like to plug that in, just a quick check. 8 equals, instead of using x, I'm going to replace it with negative 16 divided by negative 2. I know that right here, negative 16 divided by negative 2 does in fact equal 8, so this checks out. All right, moving right along. Here's our next example. 9 is the sum of negative 13 and a number to set us up. 9 is, so 9 equals, and then it says the sum of negative 13 and a number. So sum, I know, is addition. And so then I have negative 13 and just some number. 9 is the sum of negative 13. Okay, still feeling good. So 9 equals negative 13 plus x. And then I want to get this x all by itself. So it's a positive x. So I'm going to do the opposite of whatever that other term is. So negative 13, the opposite of a negative or a minus 13 is a positive or a plus 13. So I'm going to add 13 to both sides of my equation. So then I end up with 9 plus 13. I get a positive 22. Bring down my equal sign. This just gives me a big fat 0. So plus x, or just x. But then remember I said that that variable always has to be on the left side of your equation. So that final answer, when I switch those around, I get x equals 22. And I'm not going to waste time checking it. But like I said, if you'd like to just plug it right in, negative 13 plus 22 does give us a positive 9. All right, and then one more example is triple a number is equivalent to 27. Okay, so if I'm tripling a number, I know that that's like 3x. And obviously it says is equivalent to, which is the same thing as equals. And then my last thing is 27. So triple a number is equivalent to 27. I set it up correctly. Now just to get x by itself, I'm just going to, because this is like multiplying, so 3 times x. The opposite of multiplying would be dividing. So divided by 3 on both sides. My final answer, x equals, and then 27 divided by 3 gives us a positive 9. And again, if you'd like to just kind of quick check that, since x is equal to 9, I know that I could plug 9 in right there. Just my quick check would be 3 times 9, and it does indeed equal 27. All right, so the last thing that you're going to do is you are going to try these 3 questions on your own. So please go ahead and pause this video, work these 3 out, and then push play to make sure that we are on the right track. Alrighty, so take a look here. Example 5, that equation, sorry, I'm in the habit of expression. That equation should be x minus 10 equals negative 3. And then to get x by itself, you add 10 to both sides. Final answer, x equals 7. And then for example 6, 14 is a number split in 2. So I'm dividing, because we know that split means division. So the opposite of dividing by 2 is multiplying. Final answer, remember that x has to be on the left side, so x equals 28. And then this last one, negative 27 is the product of negative 9 and a number. When I divide those suckers out, I end up with x equals 3. All right, hopefully you feel good on this. Good luck on our problems tomorrow.